Okay, so let's look at 23. So 23 says a driver of a car going 25 meters per second suddenly notices a stop sign 40 meters ahead. Braking deceleration of the car is 10 meters per second squared, but it takes the driver 0.75 seconds to get the foot on the brake and get it applied. Determine if the car runs the stop sign and what was the maximum initial speed at which the car could be moving and manage to stop still at the stop sign. So what I said was, okay, well, here we go. Okay, it's working. I said, well, I know the initial speed is 25 meters per second. I know the car has 40 meters to stop. The final speed is going to be 0. And the acceleration is -10. So that's what my givens are. So I said, well, let's see. I know that the average speed is equal to distance over time. So I want to see how far does he travel when he puts the brake on. So his speed was 25 meters per second. It took him 0.75 seconds to realize that there was a stop sign up there. So during that time, he traveled 18.75 meters. That left him 40 minus 18.75 meters to stop in. So his stopping distance was 21.25 meters. Okay, then I said, well, VF squared equals VI squared plus 2AD. So I know his VI was 25. Don't forget to square it. His acceleration was -10. And he had 21.25 meters to stop in. So I checked for his final speed, and it was not 0. So he did not stop at the stop sign. Okay? And then it says what speed would he have to have in order to stop at the stop sign. So I said, well, let's see what that would need to be. So for part B, I said, okay, VF squared, VI squared, 2AD. I need this to be 0. That's my VI that I'm looking for. You know your A is your -10. And you know he has 21.25 meters to stop in. So you should be able to figure it out like that. Okay? So hopefully that will help you get through that one. You know what, though? I don't think I like this answer right here. So I'm going to pause and think about that one, because I'm assuming when I worked that one that he had that 18.75 meters of stopping distance. But if he has a different initial speed, then this would be different. So let me go back and play with that. I'll be back, all right? Let me pause it. Okay, so I looked at part B again because I didn't give you the right approach, because I forgot a little significant thing. So let's take a look. Okay, so now part B says determine the maximum initial speed at which a car could be moving and manage to stop at the sign. So you have to remember that he goes some distance during the reaction time. So I said, well, 40 meters is the total time, and it has to equal to D1 plus D2, where D1 is the reaction time distance traveled, and D2 is once he puts the brakes on and brings it to a stop. So I said during D1, he has during D1 he has an average speed, which we're just going to call VI. We don't know what it is. And he has 0.75 seconds to react. So there's my VIT. That's my average speed times time equation. And then during D2, well, at D2 I had VF squared equals VI squared plus 2AD. So this would be 0 because he's going to come to a stop. So -2AD is equal to VI squared, which is what I'm looking for. So -2, A is negative, what did we say was -10? Okay, so let me rewrite this. I want to solve for D. So I'm going to bring this over to the left-hand side, so -VI squared over 2A is the same thing as d2, because that's when he's putting his brakes on. So instead of d2, I'm going to write in negative vi squared over 2a, and that'll be his d2. So then you do the math. You have 40 meters, and you have 0.75 seconds vi minus vi squared, which we don't know, over 2 times negative 10. So now I have 40 meters equals 0.75 seconds times vi. Okay, that negative and that negative make that be a positive vi squared over 20. So I need to get rid of this little rascal, so I believe if I can do algebra correctly, if I multiply this by 20, this by 20, and this by 20, I'll get rid of that in the denominator. So this becomes 800. This 20 times 0.75 is 15 times vi, and this is just plain O plus vi squared. So then I had to do the quadratic, and it was just so much fun, and when I did the quadratic, I believe that I got 21.76. So you might need to double check my math, but I think we're good there. Alright, again, you might want to pause, because I'm fixing to get rid of that stuff and move on. Okay. So now we're on 24. Under what circumstances is the effective air resistance negligible on a falling object? And then when is the use of 9.8 meters per second squared most valid? Well, not real sure what he's looking for there. When you reach terminal velocity, though, what happens at terminal velocity is the air resistance in that direction balances the weight of the falling human, and you no longer accelerate. So I'm not real sure what he's looking for there, so you might ask him. Okay. 25 says one rock is dropped from a cliff, another is thrown downward. When they reach the bottom, which rock has the greater speed, which has the greatest acceleration, and which reaches the ground in the least amount of time? Okay, so we have Vf squared vi squared plus 2ad. So they're both going to accelerate with the same rate because gravity is going to handle both of them the same. So neither of them has a greater acceleration. Now, if this is 0 because I just released it, then this Vf is not going to be as large as if I had given it an initial velocity. Because if I give it an initial velocity, then that squared plus the 2ad is going to make this value get higher. So the one that reaches the ground in the least amount of time should be the one that is thrown. And when they reach the bottom, the one that has the greatest speed should be the one that is thrown. They should hit both with the same, they should both have the same acceleration because it should be gravity. Because as soon as you release that from the throw, gravity takes over just like it did for the one you dropped, okay? A stone is dropped into a very deep hole in the ground. It hits the bottom after falling for 2.80 seconds. How deep is the hole? And what is the impact velocity? Okay, so we want to know how deep the hole is. If it's dropped, we can assume that that's true. We know that if it falls freely, that's true. I don't know if you use 9.8 or 10, but that would be true. And it's going to hit 2.8 seconds. So you should be able to find the depth of the hole, and then you should be able to say Vf equals Vi plus At. This is Vi, you know A, and you know T. So that should not be a big deal. All right, let's look at our time. Oh, we're doing great. Okay, let me see if I can get back to the next page. Alright, so let's come over here and scroll on down. Ooh, we still got a few more to do. I'm sorry, 27 through 30. Okay, so let's see what's going on here. Okay, 27 says, alright, let's X that puppy out. Alright, now let's see if we can make this work. Okay. 27 says a ball is thrown upward with initial speed of 15 meters per second. Find how high it rises. How much time does it take to get to the maximum height? How much time does it take for it to fall back down? And what velocity is? Okay, so this is all that's going on there. Okay. So if it starts out initially at 15 meters per second, if nothing interferes with the trip, it should get back here at 15 meters per second. Because the only thing that's changing this motion is gravity, and gravity is going to be the same whether it's going up or coming down. Okay, so here the final velocity is going to be 0 meters per second on the way up. but that's also the initial velocity on the way down. Now I tell my kids on the way up I'm going to use negative 9.8 because gravity's slowing it down, and the way back down I'm going to use gravity is positive 9.8. I don't know what your teacher has you use. You'll need to talk to him about that, but this always makes sense to me. Okay, so if we're looking for the maximum height, we can do because we know this is 0, this is 15, this is 9.8, and it's negative because it's slowing it down, and solve for our d. Okay, not a big deal. How much time? All I did was take VF equals VI plus AT and rearrange it for my time. Okay, and I know that VF is 0, so negative 15 over negative 9.8 would give me my time. Then it says how much time does it take for it to fall down? Well, if it goes up the same distance that it falls, which it should take it the same amount of time to fall down that it did to rise. So that's pretty simplistic. You have a very symmetrical situation there. Alright, a punter goose and punts the football straight up. The hang time, total time in the air, is 4 seconds. So that means that it goes up for 2 and down for 2. Because remember, hang time is the total time in the air. Okay, so how high? So I'm going to use this as the distance it falls, because if I talk about the distance that it falls, which is going to equal the distance it rises, then my math is a lot easier because I can say when it's falling, this is 0. So you know your gravity is pulling it down at 9.8, and the time is 2 seconds. So go for it. Initial velocity in miles per hour. Oh, of course, we have to do that to you, don't we? So does the ball have? So I would say that VF equals VI plus AT, and VF is 0 at the highest point. You're looking for VI, you know A and you know T, so you're going to have 9.8, and this is on the way up, so it's a negative 9.8, but I want to bring the negative over here, it becomes a positive. T is 2 seconds, so there's my initial speed in meters per second, but you got to take that 19.6 meters per second and change it to miles per hour. So that's just some dimensional analysis practice, no big deal. Alright, I'm going to pause and see what this little AP one is about. Okay, so I read this and we did something similar to this one when I was teaching, but really not real hard. Okay, so you're trying to figure out what is that distance right there. So here's your window. It's 3 meters from here to here. Gravity is accelerating at 9.8, and it takes it 0.2 seconds to go from here to here, if I read it correctly. Yes. Okay, so I know that it had initial speed of 0 up here somewhere because it was just dropped. It has a final speed after it's fallen that distance. That final speed after it's fallen that distance is also the initial speed when it begins to go past the window. So if I can find this right here, then I can work backwards and find out what that is right there. So I said d equals 1/2 AT squared plus BIT. It has to fall 3 meters. Gravity is 9.8. I don't know if y'all are using 10 or 9.8, but I'm going to use that right there. Times 0.2 seconds squared is plus VI, which I don't know, but I'm trying to find, because if I find that, then I get that, and I'm going to be home scot-free. So there's my 0.2 seconds. So I should have said that 0.5 times 9.8 times 0.2 squared is 0.196. So 3 meters minus 0.196 is equal to 2.804. So 2.804 meters divided by 0.2 seconds would give me my VI. So divide that by 0.2, and I got my VI to be 14.02. Okay, so that would give me the speed that it has right as it gets to the edge of the window, and then I could go back and do VF squared equals VI squared plus 2AD and solve from the very beginning. Find out what this distance is. My initial speed is 0. I already knew that my VF at the top of the window is equal to the VI as it begins to go across the window, and we solved for that right there. So I know that value, I know that value, I can find that distance. And then you can easily find that speed by saying VF squared equals VI squared plus 2AD, and you'll say this is 0, and this is gravity, and then the distance is going to be from here all the way down to the ground. So you can easily calculate that distance and find your final speed. So pause it if you need to study that one. Alright, let's look at the last one. Well, of course it's an AP, so I'm going to stop and then I will come back. Okay, so the last one. So it took me a few minutes to even understand what the question was asking. Not sure that I'm going to work it correctly, but we're certainly going to give it a try. Okay, so the elevator's going up at 1.1 meters per second, so we're going to call that positive. And the guy lets go and falls in free fall for 1.5 seconds. So I said, well, BF equals VI plus AT. So if BF equals VI plus AT, so if up is positive, that would be 1.1 plus down is negative 9.8 times 1.5 seconds. So if I take 9.8 and multiply it by 1.5, I get 14.7. I'm going to make that negative because that's what I chose for the direction, plus the 1.1 upward. So he's moving at 13.6, negative 13.6 meters per second. So that means that he's moving toward the ground 13.6 meters per second. Alright, then how long is the rope? So I said, well, D is equal to 1/2 AT squared plus VIT. So A is going to be my negative 9.8. T is going to be my 1.5. My VI is my 1.1 times my 1.5. So I solved for that and did the math. And then it says how much closer to the ground is the man at the instant he is caught by the rope than when he was at the instant he let go. So what you have to realize here is that the elevator continues to rise as he falls. So you have to take that into consideration as you're figuring out how much closer to the ground is he than when he was at the very beginning. So play with that. That one's I'm not real swift on, but play with that one, see what you can do. So I will post these, and hopefully there'll be some kind of help to you. Take care.